quiet, please. If you can hear me, snap once. Thank you. All right. We've been working with exponential functions, and we decided, Ms. Morell and I, that this week, with this weird day off in the middle, today we're going to review what we did on Monday and Tuesday. So rather than moving on to the next section, we're going to practice looking at these exponential functions, how to set up equations, how to graph them, and how to use a calculator to help us out. So this packet we're doing in class today and will not be additional homework. Whatever we get done, and we'll turn it on in. You do have your homework packet that like Guillermo said, is big enough for home. So today we're going to do a little bit of it together and a little bit where you're working on your own and kind of a back and forth. Right? And so I can't tell what they can see. I forget how to... Oh, good. There we go. Okay, good. So, guys, we're on the 5.2 skills practice packet. All right? And we're on 5.2 skills practice packet. It's a separate little packet from the homework. All right. Horizontal asymptote. Who remembers? Oh. Are they getting the packet? Natty, do you have the packet? Yes, okay. I see Mr. Marwig with something. I thought maybe he was handing them out. Right at the end of our day, Sam, right at the end of our day on Tuesday, we were talking about a horizontal asymptote. Okay, screen down, please, Sam. Who remembers what that horizontal asymptote is? It has something to do with the shape of an exponential graph.
Isn't that the lower part of the exponential?
It's the lower part. And if I don't have different colors, but you can imagine what we tried to do is take this on back a lot of years. It was one of them. It was like Uptown's population. And we were trying to find zero, but we couldn't find zero. We had to go farther and farther and farther back. And what this line is doing is it's steady, 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 only going up a tiny bit, and then it swoops up a lot at the end. The horizontal asymptote is a line that's like a boundary. This is the asymptote. Okay? I don't care if you put this into words. Draw one of these curves and give yourself a dotted line underneath. What happens with the asymptote is it's a divisible force field. The graph gets closer and closer and closer to it, but never touches. These exponentials have a vertical asymptote also. We didn't explore that, and maybe we won't, because they focus a lot on the horizontal one for us. But as you can see, if we tracked this curve on up, it would kind of do the same thing. It would go up, 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 and then skim. It kind of reaches a level and doesn't go farther. Those are called asymptotes. They're invisible force fields. They're kind of fences that hem in the edges of a graph that gets tiny bit closer each time that it moves. All right, asymptote. Is that big enough, or should it be bigger? Okay. Write a function that represents each population as a function of time and they gave us an example for a town, Blueville. Jerry, could you read about Blueville for us?
Sure. Blue, wait, one, right?
Yes.
Blueville has a population of 7,000. Population is increasing at a rate of 1.4%.
Okay, so important features here is that 7,000 and the 1.4%. Okay, look at what they have worked out for you. This needs to go away, please. Yes, they show you how to do this problem. They give you the generic formula with the P0, the 1, the R, and the T. Then they show you how to plug in the information and then a simplified form of that. That's what we're going to do on the next several problems. You needed to, in the problem, find initial population, which is P0, and the R. You also needed to take that R and turn it into its decimal form. All right, so number 2, Youngstown. Oscar, can you read about Youngstown, please? And one thing else to notice is we had some problems that are increasing problems, and then I could see one right below it that's a decreasing. So that'll be something to be careful of as you read the problem. The first thing you're going to write is P of T equals. Now you don't have to rewrite the formula each time. All of these are the compound problems. You start with P0, 12,000. You're going to times it by 1, and then if it's increasing, it's going to be 1 plus R. Our R is 1.2. Chris V, how do I make that into decimal form? 0.012, and then the T is a tiny exponent raised up high. They take this one more step up here in our sample problem and simplify the addition of 1 plus R, 12,000 times 1.012 raised to a T. Okay, at your tables, please do 3 and 4. Write some formulas for Greenville and North Park. You don't need your calculators. You're reading 3 and 4, and you're setting up the equations, please. Guillermo. 2 is up there. You might want to copy it down. What's that?
Oh yeah.
Scratch or hand?
Is this all compound?
Yes.
Alright. So for the decrease, you
You go 1 minus. Okay. Instead of add, it's going to be minus. Oh, you're doing subtract. This is the not times. It's either going to be add or subtract. You got to look there. This one's decreasing, so it's a minus. So what you could use a calculator for is 1 minus.
Oh, is that what you got for
Oh my god.
We're gonna now simplify this by going ahead and doing that subtract. So take it one step further. This needs to be put away, please. I don't want it to. Plenty of math. Go ahead and simplify it by doing that subtract. Who has a nice simplified version of number 3?
8,000 times 0.93.
Bless you. To the T, yes? Do you guys agree with Sam? 0.983?
Yep.
Okay, that's after you've done the subtract. It was 1 minus something. Go ahead and simplify. Bless you. Do the subtract. P of T equals? Tony, do you have a simplified version? 9, 7. That's it? Okay, yours must have rounded. Yeah, it must be rounding to 2 digits. And a little t up top. Don't forget the little t. Exponent t. Okay, next page. Waynesboro. Waynesburg. Hello, Miss Marks. Can we help you? Okay. Waynesburg. Anna, could you read about Waynesburg for us?
Number 5.
Right below number 6.
Represents the population as a function of time. Determine the population after each given number of years. Round your answer to the nearest whole number.
Thank you. Initial population 16,000. Rate 1.5. Jerry. This problem is increasing, and could you stop that, please? If you notice, they already give you a simplified form of the equation. They gave it to you in 2 places. All they want you to do is figure out what is the population in a certain number of years. For this one right here, we're going to do P of 3 years. We're going to go 1600 times 1.015 raised to the 3. So we're substituting in right here a 3 because it's 3 years, and right there a 3. The 3 represents time. It's a t in our generic function. We're going to go ahead and substitute it on in. This is a calculator problem. On clear 16000 times 1.015 raised to the 3. Enter. 16730.85. Now we have 4 other years they want us to find it for. We have a couple of ways we can find that with our calculator. What's one way? One way is redo the whole problem. What's another way that may be quicker? Excuse me? Y equals. Clear out old functions. Put the generic function on in. 16000 times 1.015 raised to a t, or a variable. What am I going to do with that y equals then to figure out something in different years?
You can go down to Y2 and enter Y2.
Well, that would be if I had populations.
Did you go to second calc?
Second calc.
Anderson?
Intersect would be if I had value. This one, if you know time, you're going to use the value function. If you know years and you want to find out time, you would use intersect. So we're going to use value. We just push enter. It takes a tiny bit to graph it. And then it pops in an X. What do we do next?
Put in 5.
Put in a 5. Enter. What do we know for population? Where do I see it on the screen?
The Y axis.
It's the Y. So the population in 5 years will be 17236.5. Actually, does it make sense to have 0.5s? No, because we're talking about humans. It does if we're talking about money. What?
Have their wisdom below entity or something.
Yeah, there's some possibilities. So we should probably round that up to 17237 people. Or round it off. Okay? All right. Do 10, 11, and 12, please, while I walk around.